Hey Gators, welcome to the next part of Lab 7. So as you recall, we already built uh, recoded versions of all the delinquency variables that we are interested in Lab 7. So as promised, I was going to teach you how to put these together into a scale. So remember with scales, we're shoving a lot of pieces together and summing them into something ultimately that's going to tell us an amount of a much larger behavior or topic that we're interested in. So the way we do this is we actually go to the transform menu and we're going to compute a variable. This is something we haven't done very often. So go to compute variable and you're brought into a little window that looks like this. So we're going to make a delinquency scale and your cursor is already in this area called target variable. So you're going to type in delinquency scale. Okay. So that's what we're going to make. And it says, okay, now I need you to show me how to build it. But once I'm done building it, you're going to equal this delinquency scale over here. That's what you're going to do. So essentially, we've already done some of the groundwork to do this. So we're going to scroll all the way down to the bottom. And again, you can expand this window a little bit so things are a little bit easier to see. I like to do that rather than working in an itty bitty tiny screen. And we are literally going to add these variables together. Okay, so we'll start with painting graffiti recoded. We're going to pop that one in there using the arrow button, and then you're going to use the calculator function below to hit the plus sign. The next one we're going to do is damage to property. Use the arrow to put it into your numeric expression and click the plus sign. Keep going and add all 15 variables in there, making sure you use the plus sign in between each variable, because we're literally writing a numeric expression that says, hey, SPSS, take this variable, add it to this variable, and add it to this variable, and add all these variables together in a list. Okay, so again, make sure you do that plus sign, and then you do the next variable, plus sign, steal a car, plus sign, stealing something more than $50, plus sign. And again, you can pause me if you don't want to hear me talk. Keep going until you have all of these items in there. And it's nice because they're all right next to each other, so you can just go grab them. The very last one is the loiter variable, or being loud or rowdy. Okay, so essentially you have 15 variables that are all going to be added together to make a delinquency scale. All you do once this is complete is you click OK. And it's kind of like, well, what actually happened, Jensen? You get some output here at the bottom that is syntax that shows you that SPSS computed this delinquency scale, and it's kind of like your receipt. It gives you a list of all the things you just asked SPSS to do. And you're like, wait a second, where's my scale? Let's go take a look. Again, it's in your data. We have to go run a frequency to see it. There it is. Okay, so here's the bottom of the data set where we had all of those recoded variables. It's a new variable you just made, so it's on the next available line, which is at the bottom of the data set. So here's your delinquency scale. We'll take a look at it in just a minute, but let's go ahead and label it. So I'm going to type delinquency scale in the label just by clicking on the row, and then we don't necessarily need to do any value labels, which some people go, why not? That seems kind of weird. We've done that every time. We don't, because the numbers are exactly what we want them to be. And I'll explain that this way. You have just summed 15 different behaviors into a delinquency scale, and all of those behaviors were given 1 point apiece. So you're going to have a score from 0 to a very high score of 15. So giving a yes or a no response on each of 15 questions is going to let us add the 1 or the 0 on all of those to give you an average or a score. So now we have an interval variable. We just took a bunch of ordinal variables and summed them together and recoded them so that we could come up with a delinquency score. So now we know how much delinquency you're doing across 15 different behaviors. So we want that number to represent itself. If you scored a 5, then a 5 is a 5. If you scored a 10, it's a 10. It means you got 10 out of 15 of those behaviors. So there's nothing to label. The number represents exactly what we want it to, the quantity or the amount of delinquency the kid did. Okay, so let's run a frequency on this variable. So we're going to go up to the Analyze menu and ask for descriptive statistics and frequencies on our delinquency scale. Remember, we recently just ran frequencies on our recoded variables. We're done with this part. SPSS tries to be helpful by saying, hey, you just did these variables. You want to do it again? And you say, no. Thanks for trying to be helpful, SPSS. You put it back. Okay? Now, again, this is where some people get a little bit stuck and they go, hey, where's my delinquency variable? Sometimes this list over here doesn't always repopulate. So it's always good to hit the reset button just to refresh SPSS. Sometimes it has to catch up with itself of something you just built, and you should be able to find your newly created variables at the bottom. So there's our delinquency scale. We'll pop it into our variables. Let's click on the statistics button. We're going to add a few statistics like the mean, the median, the mode, and also the minimum and the maximum, just to let us see all that's going on in this new variable that we made. Then you'll click continue and OK. Here is your delinquency scale. So right here, these are all the scores that all the kids provided. So they start at 0. Most of the kids haven't done anything delinquent, so that's probably a good thing, right? But there are quite a few kids that did one of those 15, right? We wouldn't call them seriously delinquent, right? You know, they're dabbling with trouble, but not getting into much of it. But then you get kids that are scoring 3, 4, 5, 6. These kids are doing more stuff, and often more serious stuff too. So there are 6 kids that have done all 15. And you go, wow, that's a busy kid. So your most delinquent kids are going to have the highest scores at 10 or above, meaning they've done 10 out of those 15 behaviors or more. Your kind of kids that are medium delinquent are probably going to be between 6 and 9. And the kids that are a little bit delinquent are going to be maybe between 1 and 5. And then the kids that really aren't delinquent are your zeros. They've done none of them, right? Because 0 equals no, I've not done that. We have a total of 6,401 kids. We had 103 kids that turned up in missing data because they refused or responded not applicable. But we still have delinquency scores on most kids in the data set, which is pretty good. Let's go back up here. The average score on those delinquency kids was a 2. Makes sense. Most kids are not terribly delinquent and getting into trouble all the time. So actually the mean, I'll correct myself, was a 2.7. The median was a 2, right? And the mode was a 0. So people go, wait a second, is this normal data? Because usually your mean, median, and mode are about the same number, right? So they all should be 2 or near a 2, right? And you go, okay, well the mean is a 2.7, the median's a 2, but the mode is a 0, so what's going on there? Well, that means that most of the kids in this data set are not delinquent. So the data is a little skewed. You have a lot of kids that have really done none of the above. Okay, so they're not necessarily getting into trouble. So yes, this is not terribly normal data. That's okay, we can still analyze it, but this is good for us to know. And again, the minimum score was a 0, the maximum was a 15. That makes sense because we had 15 items in the scale. We now know the highest and lowest scores that are possible, and we also know what those scores mean. The low scores meaning no delinquency is a 0, and then 1s, 2s, and 3s are going to be low delinquency. The high scores, 13s, 14s, and 15s, are going to be high delinquency, meaning they've done a lot of delinquent stuff. So I'm going to pause here for a moment because you've probably just answered a few more questions on your lab that you're going to want to jot down. Hey there! So now that you've been able to capture some of your answers on the lab, I'll stop floating around the screen. Let's get into the last part of the lab, which asks you to run a regression. So as you may have noticed, this lab is kind of short and it doesn't have all the usual prompts you would normally have in a lab. So a lot of times it says, hey, recode this variable or make a variable that looks like this and then tell me the coding scheme you used and then report some kind of statistic or information about that variable so we know you built it correctly. We're not going to do that this time. You've done a lot of recoding at this point in the class and you should have those good habits in place of how to check your variable and make sure it is accurate. So I'm going to kind of turn you loose a little bit and make sure that you are prompted and that you can do a little bit of your own troubleshooting when you build your own variables. So the next question in your lab talks about run a regression that assesses whether or not the amount of delinquency a youth commits is predictable by their gender, their sex, and how old they are when they first drank alcohol. So essentially, we're predicting how much delinquency you do based on what gender you are and if you were an early drinker as a kid. Okay, so I'm not going to give away the answer to this question, but again, when you think about which variable is independent, dependent, and control variable, I'll give you a couple of hints. So the dependent variable is the outcome which you seek to predict, right? It's the result of what happens. So it's usually the thing that has a lot of variation to it, given something else we know about you. The independent variable is often the very first variable of interest that we come into contact with, the one that we think really does predict that outcome. And we call those predictor variables, independent. So regardless of what your response is on that independent variable, we think there's going to be a subsequent response on the dependent variable based on what that response is. Okay? And then usually other variables listed after that are considered control variables. So they're not the main focus of the test or the regression or the analysis that you're doing, but they are other variables of interest that we want to see also if they are predictive or do they matter. So they are subsequent variables that we use later. So when you think about this question, we want to determine the amount of delinquency a youth commits and see whether it's predicted by gender. And we also want to take into account or in consideration how old they were when they drank their first drink of alcohol. So right there, you should be able to determine which one is dependent, independent, and control. Okay? Now keep in mind, control variables are really just other independent variables that you think are also predictive of the outcome. And we do that all the time in research, just thinking, you know, it's not just one thing that predicts a behavior or an outcome. There are a lot of things that can be predictive of it. So we like to account for those other things that we think also matter. Okay, so the next note on your lab says you need to decide if the variables need to be recoded or not before running your analysis. This part I'm going to help you with a little bit. Okay, so we know we already built a delinquency variable, so we're pretty good there. But now we have two other variables that we have to work on. One is gender, and the other one is their drinking age. Let's start on the gender variable first. So the gender variable, if we go all the way to the top of the data set, and I will move me over a little bit, it's actually right at the top where you see row number 9, biological sex, wave 1. So at the time this survey was given, they just gave basically a male-female response to this question. Of course, we know there are other responses that people can give when it comes to their biological sex or their gender identity, but in this particular survey, it was male, female, 1 or 2, or number 6, refused. Okay? So for purposes of our study, we actually are going to recode this variable. So we're going to change this from a 1-2 variable into a 1-0 variable, because in particular, we want to look at being female. Now we know, because the literature we've looked at, the research and the science has already told us that there is a gender relationship when it comes to delinquency. So we want to see if that's actually true, if we run our own test, if we're going to match up to what the science says. In particular, we know that females commit much less delinquency than males, but we want to test that idea to see if that's true. So in this case, when we're going to recode this variable into a dummy variable, a 1 versus 0 variable, we usually make the category of interest the 1, and we make the category we want to compare to the 0. So in this case, we're interested in females, so we're going to make females a 1, and we're going to make males a 0. Now, there really are only a couple of responses in here, male, female, refused, so we don't necessarily have to jot this down, but if you have trouble keeping track of the details, then you might want to do so. But this one I can usually keep in my head. It's very common in a lot of data sets for 1 to be male and 2 to be female, and then you just have to keep track of what they use to represent missing data. But this one we can do pretty quickly and pretty easily. So yes, we are going to recode gender. 1 is male, 2 is female. We're going to make the males a 0. 1 is now becoming a 0, and we're going to make the 2s a 1. The females will be a 1. Okay, so let's do this recode. So go to the transform menu, recode into different variables, and we're going to go ahead. I was recoding some other variables earlier. If you have any variables still in here, put them back and navigate to the biosex variable, which is at the top of your list. Put that variable inside the expression, and we're going to call this variable gender. And in the label, we can type gender, and then we can go to old and new values. So in here, again, I was working on other variables, so I'm going to remove all this stuff. And again, this is SPSS trying to be helpful by saving the last stuff you just did, if you need to reuse it again. But remember, we're going to take those males who are an old value of a 1, and we're going to make them a new value of a 0, and click add. And then for our females, the old value of 2, we are going to now make a new value of 1, and click add. And then again, the value of 6 is a refused response. We're going to make that a new value of system missing. And then of course our famous system or user missing, a blank response, we're going to treat as system missing. So this is what your coding scheme should look like. 1 is 0, 2 is turning into a 1, a 6 is missing, and user missing is also system missing. So if you have that scheme, you can click continue. All right. Okay, so again, click OK, and it just gives you the output that it was done. So you need to go run a frequency of your new gender variable. So scroll all the way down to the bottom. So I kind of paused and skipped a step for a moment. But you should have a new gender variable as your latest variable that you created for your lab. And you can click Analyze, Descriptive Statistics, and Frequencies. And we're going to go all the way to the bottom and pick our gender variable. And just to be super convenient with a comparison, we're going to scroll all the way back up to the top and grab the biosex variable and also put that side by side with the gender variable so we can check for accuracy. So once you have gender and biosex next to each other, you can click OK. And that'll generate output of both gender and biosex. Now essentially, you should have numbers that are pretty equivalent from the biosex to the gender variable. Okay? Now, one step that I didn't show you was labeling your variable. Okay, so you're like, I have 1s and 0s. How come my screen looks different than yours? Again, when you go create a new variable, you can click on that blue box at the end of the values column where your new variable is, and you can say, okay, in this new variable, 0s are male and 1s are female. And once you have those labels in place, you can click add and you can click OK. So I usually like to label first before I run the frequency, and I actually did that step already. I just didn't show you. So again, once you have that in place, you should see that when you compare, and you can run the frequency again once you have everything labeled, you just go back in, Analyze, Descriptives, Frequencies. It's going to save the frequencies you just ran. That's what you want to see. Click OK. And again, it'll give you the output. So you can now see everything nicely labeled, males and females, males and females. So all we were doing was just kind of re-tagging these responses for males and females in this variable. So I have 3,147 males. I should still have that same number in the new variable. They're just labeled a little bit differently. They're just taking on some new organization or new categorization, if you will. Okay, so our gender variable is now ready for analysis, but we have one more variable to check out. Let's give it a look. So drinking age. We know the science also tells us that drinking at a young age is incredibly risky for a kid. And it can be kind of a gateway behavior into other troublesome behaviors for that kid. Okay, so we're going to put our cursor in the label column, and you're going to do a Control F, and we're going to search on alcohol. Okay. So this was drinking alcohol and driving. That's not the one we're interested in, so we're going to hit Find Next. Another one on drinking alcohol, Find Next. Drinking alcohol outside the family, no. There we go, age I first drink alcohol, okay? So we can close this search menu for now. This is the variable we want. It's on row 1758. Okay, I'll bring it up a little bit so you can see it better. Okay, so this variable is the age at which you first drank alcohol, and the values are 1 year, 2 years, 3 years, 4 years, 5 years. Yes, there are kids that report having had alcohol as a toddler. I know, it's kind of interesting to think about that. Okay, so this is their age in years that they said, I started drinking alcohol at this age. This is when I had my first drink of alcohol. Okay, so we start out as toddlers, then we get into elementary school, and finally into high school. And they can't be older than 18 or 19 because those are the oldest kids in our survey, right? And then of course we have refused, legitimate skip, maybe they haven't had a drink of alcohol or drinking when not with a parent, or they don't know, okay? So these are our missing data categories right here. Okay, given the way this variable is coded, I'll close this for now. And I already have the missing categories defined as missing between 96 and 98. So I know those numbers are going to be treated as categories rather than numbers. This variable is actually ready to go out of the box. I don't have to recode it. I can analyze it as it is because 1 year literally means a 1-year-old. I don't have to do any fancy changes or anything like that. So I'm now ready to run my analysis. So let's go ahead and get into regression. So we're going to go to the Analyze menu and click on Regression. Linear. The reason I know we need to run a linear regression is because our dependent variable is interval. It's a quantity or an amount of something. So we click on linear and we're provided this little box. I've already played around with this regression already, just for fun. And here is where we're going to build our regression. So it tells us this is where the dependent goes, this is where the independent variables go, and so forth. So for purposes of our lab, the delinquency scale is the dependent variable. And then we're going to use gender as our independent variable. And then we're also going to use H1TO14, the drinking variable, as a control variable. So we're going to go ahead and right-click inside this list and say Display Variable Names. And we're going to type in H1T. It'll take you to the kind of the TS's. We're going to go to the TOs. See if we can get a little further. H1TO. There we go. So it's kind of about, I don't know, 1/5 of the way down on the scroll bar. There's a lot of variables in here, I know. So there's H1TO1. We'll click down just a little bit further and get to H1TO14. That is the age you first drank alcohol variable, okay? H1TO14. So we're going to put that stacked right underneath the gender variable by using the arrow in the independence box. Remember, a control variable is just another independent variable, but we just kind of stack them in order of importance, okay? The next thing we need to do is click on the statistics button, and we're going to ask for descriptive statistics. Okay, we're going to ask for that additional information in this regression. Once we do that, we click Continue, and you click OK. All right, we get a lot of interesting new output here. So we have our descriptive statistics. It says, okay, here's your delinquency scale, here's your mean, and it looks like it's a little higher than usual. There's a reason for that, because we're not analyzing quite as many kids, and we're analyzing kids that also have these attributes. So the kids had to respond to the gender question, and they also had to respond to the age they first drank alcohol question in order to be included in this analysis. So again, the more requirements you put on your data, the fewer cases you get to analyze. Remember, we had over 6,000 kids in this data set? Well, not everybody answered the drinking question. Most people answered the gender question, and there was a little bit of missing data on the delinquency scale too. So we know the total number of kids we've analyzed was 2,518. The kids that gave us responses that we can look at on all these questions. Whenever you run a regression, you also get a set of correlations because you have to have correlation in order to run regression. We don't really report on this very often, so we're going to continue to scroll down until we get to the model summary. Okay, so right up here, this is R squared, and that's 0.080. And it kind of reminds you right underneath, your predictors are age you first drank alcohol and gender. So it reminds you this is your overall summary of how your model of predicting delinquency did given these predictor variables. And then down here, we also have an ANOVA test. We have to do an analysis of variance in order to run a regression as well. So again, we don't really report information in this middle box, so I want to train your eyes to go all the way down to the very bottom box, which is coefficients. Okay, so it reminds you your dependent variable is a delinquency scale, and these are your predictors, gender and age you first drank alcohol. So first of all, we know that we have highly significant predictors of delinquency. We also have coefficients that we need to interpret exactly what they mean. And I'll show you how to interpret this set of output in the next video. But at this point in time, make sure your output matches mine, that you're getting the same kinds of numbers and the same estimates as I'm getting on my screen. So that way you have the same output that you can interpret for your lab. We'll see you in the next video.